In this screencast, we're going to continue our discussion of Lewis dot structures looking at hydrocarbons. The functional group we're going to consider are alkanes. So alkanes are compounds that are composed of carbon and hydrogen. We're going to look at the first three substances in this series: methane, ethane, and propane. We're going to utilize the bonding pattern that we saw in class that's based on the periodic table. So this bonding pattern comes from the number of valence electrons available for each element to bond. So let's briefly review the case of methane. So example number 1. This is the simplest alkane. So the skill that we want to build is to take the molecular formula and convert that into a Lewis dot structure. So let's first construct a table that's going to tell us how many electrons we have to show in that Lewis dot structure. So we'll list the elements in this column here: carbon and hydrogen. So the number of electrons that each element has to have, we get that from the valence electrons of the periodic table. We see that carbon has to have 4, hydrogen has to have 1, and then in our next column here are the number of atoms each is supplying. So there's 1 carbon and then 4 hydrogens. Then finally our last column is the total. So we're going to multiply 4 times 1 to get 4 electrons supplied by carbon, 1 times 4 to get 4 electrons supplied by hydrogen. If we sum those, we get 8 electrons. So our Lewis dot structure has to show 8 electrons. So what we're going to do in this case is draw our central carbon atom with its electrons supplied for bonding. So now we have 4 hydrogens in the molecular formula. So basically what we're going to do is pair each unpaired electron of carbon with a hydrogen and its unpaired electron to get the Lewis dot structure for methane. So you can see we've shown 2, 4, 6, 8 total electrons, so that's an octet. So we've followed the convention for Lewis dot structures. And another way we can draw methane is the dash formula, where we represent, instead of 2 dots as the bond, a line as the bond. So this is a single bond composed of 2 electrons. So this is equivalent to the Lewis dot structure. So moving on in the series from methane to ethane, we're increasing the carbon content. So notice what we're doing. We now have a molecular formula of C2H6. So here's the condensed formula for that molecular formula. Let's go ahead and repeat this exercise so we see how many total electrons we have to show for this compound. CH. Remember, carbon has 4 electrons. This time we have 2 carbons. Now carbon is supplying 8 electrons. Hydrogen has 1 electron. We're supplied with 6 from the molecular formula. That equals 6 electrons from hydrogen, giving us a total of 14 electrons that we have to show. So as a warning, we've drawn the condensed formula CH3CH3. This is a convention that we're going to use to make reading these formulas easier. That does not mean that a hydrogen is bonded to this carbon and to this carbon. Remember, hydrogen can only have 1 bond. So Let's go ahead and draw in our carbon and the 4 bonding electrons. We know that this carbon has 3 hydrogens bonded to it, so let's go ahead and fill those in. There's 1, there's 2, and there's 3. So we have an unpaired electron on this first carbon. The second CH3 fragment is going to resemble this. So it's going to have an unpaired electron as well. So we'll go ahead and pair the unpaired electrons. Now we've formed a carbon-carbon single bond. And we're going to draw in the remaining hydrogens for this carbon. So let's go ahead and count the number of electrons. We have 2, 4, 6, 8, 10, 12, 14. We've verified we've drawn 14 electrons. Each carbon has an octet of electrons. And another way we can draw this are representing the bonds as lines. So here's our carbon-carbon bond. And our remainder of CH bonds. So notice that methane was strictly CH bonds. Moving to ethane, we now introduce a new bond, a carbon-carbon bond. In example 3, we're going to look at propane, which is the next higher homologue in the alkane series. We repeat the same type of analysis with our elements, carbon and hydrogen. Carbon supplies 4 electrons. There are 3 of them. So we get a total of 12 electrons from carbon. Hydrogen supplies 1. We now have 8 of those. So we have 8 electrons from hydrogen. We sum those. Our Lewis dot structure now has to show 20 electrons. So here's the name propane. The molecular formula is C3H8. That's very general. The condensed formula gives us a little bit more information about how these things are connected. From the prior ethane example,
it's 4 o'clock.
We know that this CH3 fragment will look like the following. So this unpaired electron on carbon is going to be bonded to this CH2 group. This carbon has 2 hydrogens and an unpaired electron. That carbon is bonded to this final CH3 group. There's our carbon-carbon bond, and then we fill in the remainder of our hydrogens. An alternative way to draw that is the dash formula. So this is the dash formula for propane. So again, we have CH bonds and we have CC bonds. So this is the progression from methane to ethane to propane for the Lewis dot structures of hydrocarbons.